Alright, welcome everyone. Okay. Getting everything all set up and ready to go here. Yeah, that's right. You know it. Giggity giggity. All right. Just getting ourselves ready to go here. Here, where are we? It's pretty close to the middle as possible. Alright, so you're just seeing the preliminary images here of the cave, which is C9. Just getting everything ready to go here. Alright, we're getting the guider ready to go here. But you can see this is the prominent area of the cave, which is right here. This little loop that you see there. And then you're going to get more as we go along here, so just have to wait for the guider to be ready to go. And by the way, happy early 4th of July to everyone. Guider is just about set and ready to go. So the camera on the right is only a 20-second image. The camera on the left is just a 1-minute image. just to see where we are, to make sure that everything is set and ready to go. Also, we're starting a little late tonight only because I was getting stuff ready for tomorrow night. Because tomorrow night, we're going to have lots of fun. And it does make sense going to the cave. Makes sense. Well, actually, what would make lots and lots of sense is getting the fireworks galaxy. Now, that would make sense, but we've already gotten the fireworks galaxy. And that would also make sense of actually switching filters, which I don't want to do. But, like I said, tomorrow, we are going to go after the moon. Was testing out a few things earlier this evening, getting everything ready to go for that. The prenumbral eclipse is tomorrow night at 11:05 Eastern Time. And I will be getting that. I'll have about 3 or 4 cameras pointing in that direction. So we are going to have lots and lots and lots of fun. Yeah, somehow it's showing 0 watchers, but I don't know. YouTube can be crazy. It's showing 3 on mine, but I don't know. Oh well. Sure. And I could. We can get the fireworks tomorrow. The only reason we're getting Hydrogen Alpha tonight and not other stuff is because, well, the moon is 98% full. So I'm not really going to try to shoot anything deep sky. Hello there, Stacy. And hello there, Amal. We are just getting ready to go. We just finished the eastern step. Now we're going to go north-south, and we will be ready to go. And then you're going to start seeing the graph. People are shooting off fireworks like crazy out here. Even next door, they're shooting off fireworks, which is crazy. Just nuts. Just got to be careful out there, people. Be careful. Alright, now we're going to do the north step, and then we will be ready to go. So here, let me take another image in a second here. We'll be ready and rearing to go. Also good news is we got the wide field camera back up and running too. So, yeah, the wide field. Look at this. We got the wide field going. And yes, that is the handy-dandy telescope that's on the left-hand side. Things are a little out of place here, so give me 1 second here. We are moving stuff around. There we go. There we go. We're just moving some stuff around. So we got the wide field going, and it's actually taking live images as we speak while we're getting the guider up and running. Eventually, what I'd like to do is I'd like to get everything all on this one shot. So all I gotta do is just use panels and just go back and forth. I can say, okay, here's the moon, here's this, here's that. So it's gonna take some time. I want to get this all set up and ready to go. And I appreciate everyone's patience, as I want to make this the best show out there. Is it gonna take some time? You darn right. That's the guider. That's nothing. Let's see, what about this one? What's this one? Ah, that's what I'm looking for. Put this one over in the bottom right. Alright, perfect. Alright, so now we're just about ready to guide, and we are guiding. Okay. Yeah, don't sit on the fireworks. Hose down the house. It's been very dry. Yes, it has. Hose it down. Alright, so now we are guiding. Okay, so now we're ready to start the planner. And we're going. Okay. Yeah, the clouds have definitely cleared up. It was cloudy for about an hour. And then all of a sudden it just disappeared, so... now we're golden. Hopefully nobody shoots any fireworks off. I sure hope not anyways. Now, as this gets higher in the sky, we're going to get more and more of the sky. I can't do anything about the blue telescope there, as it's there, so there's not much I can really do. But, this is a nice wide field view. It's nice. There's barely any noise, so that's good. But you get to see my blue telescope. Ha! It's kind of funny. I still don't know why it's not showing any subscribers, but who cares, whatever. So what we'll be doing is, here's how tomorrow's going to go. We're still going to get some hydrogen alpha, but along with that is I'm going to have a second mount pointing at the moon, where I'm going to have 2 cameras on the moon, and we're going to get the moon from 11 to 1, where we should be able to see the shadow on the moon. So we should be able to get that. That'll be nice. Along with that, we're also going to try planetary. So we're going to do that tomorrow too. If it stays clear. I'd like to get Jupiter, Saturn. They're pretty close to each other, so I'd like to get both of those tomorrow. So we should be in great shape with that. Also, at the same time, we're going to be getting deep sky imaging too. Let's see here. Yeah, guiding is really good right now. We're at 0.6. The guiding is phenomenal right now. And we're doing a 6-minute image with the Meade camera, and we're doing a 9-minute image with the QHY. So hopefully we should be getting some detail. At least I hope so. Look at the little cloud right there. Look at that. A little bit of cloud going through. It's just going through. You're about 2 minutes away from getting the one on the left. I know, stupid cloud just going through. Hopefully it's not going to interfere with our image. We're going to be shooting just a little bit above that, so right in this area we're going to be shooting. So the way it's moving is it's going to go and it's going to miss it, so we should be in good shape. And I'm going to flip the scene as soon as we get to the 6-minute mark so we can see what we get. Now, if you're wondering what that wooden piece is on the right-hand side, what this is, right here, this is the wooden piece that holds the roof together. So, the sliding roof. So this is the end of the roof, where I slide it over this way. And then, when I'm done, I just slide it back here. So we're pointing pretty close to north. And this camera sits below the Zenithstar 80mm refractor. I just haven't had a chance to put it in. Alright, so that image is done. We're going to flip it back. Alright, so the camera on the left is done. Let's see what we get here. Oh yeah, there's definitely some good detail in this. Look at that. That's some good detail. Right in here. You can see how it goes like this. Almost looks like it's a cave. You can almost walk right into it. This is all going to be nebulosity, all in this area right here. That's perfect. Is there a little bit of condensation on the mirror again, or on the glass? We'll watch it. We'll continue to watch it and see what happens. But I think there is. I could be wrong. Let's check the next image just to make sure, but I think there is. Or that very well just could be me stretching the image. Hang on, let's see. Yeah, I think it's just me stretching the image. Yeah. Yeah, it was super humid today. But looking at it, it's not terrible. Let's see, I'm trying to... Yeah, we'll see what the next image looks like, but that's not too bad. Yeah, we'll see. But the one on the right should be just about done. What I'll do is I'll change the histogram here because that's going to get really... There's going to be a lot of data here. Alright, that's a lot of data here. This is a 9-minute image here. Whew. That's very red. Oh, now that is red. My question is what does this look like when I extract it? Let's see here. Let's take a look. Shall we? Alright, let's see. We got nebulosity pulled up. Let's see. Well, the next image is done. Well, that actually looks pretty good. Yeah, that's pretty good. But I'm trying to find it in the QHY. Yeah, I gotta increase the exposure. I think it's right here. But I'm not really sure. Only one way to find out. Let me save it. And then let me put it into Plate Solver and see exactly where this is. I just want to see, just for the fact of looking at this, I want to see exactly where it is in the sky. My guess is it's right here. If I had to take a guess. So we'll see. What else I'm going to do is in 2 minutes we're going to increase the exposure on the Meade camera because guiding looks really good. So I want to make sure we're running at about 0.7. So that's really, really good. So it's doing a plate solve right now just to see. And of course now we can flip back to my wide field, which is right here. And a little bit of clouds coming through on that one section there. There's a little bit of clouds. Still hasn't found it, which I'm surprised. And by the way, happy 4th of July. We are now officially the 4th of July. How about that? Word up, it is the 4th. Shoot those fireworks off, because it is go time. Oh yeah. Still hasn't found it. Just like to know if that's where it is. Alright, so the next image is done. And it's trying to find that image. Interesting. Alright, let's see what we get here. Yeah, that looks pretty darn good to me. Alright, so now that we got enough of these, let's take a look here. So this was the first one. We can get rid of that. We don't need that one. This is gone. We don't need that one. No. Okay, good, good, good. So we don't need 3. We don't need 4. Alright, so this is gone. So 3 is gone. 4 is gone. Alright, so we've taken 3 6-minute images. We're going to crank this to 10. Okay. C9. Okay. Whoops, dropped my phone. Oopsie. Alright, now we will pull up Deep Sky Stacker Live. Okay. Well, what the hell happened? Holy shit, what happened? Apparently we lost, wonder if there's clouds coming through. Flipping the chicken. That was weird. And how it like the star just like all of a sudden just got lost. It's crazy. There we go. That's what I'm looking for. Okay. There we go. Trying to get the histogram just right. Trying to... Trying to make it just a little bit darker. Try that and see if that works. Alright. That's a little bit better. Oh, sweet. 10 minutes and the chicken will be done. This one's a little bit of a difficult object to get, but we're getting it. We're getting the information, which is great. Yeah, there was a little bit of clouds that went through. No, interesting. That's part of the reason why all of a sudden it just like decided to not do so well. Interesting. Oh, wow. Yeah. The clouds did that. Kind of interesting shot nonetheless. Wow. They kind of look like stars and stripes. That's kind of neat. Well, look at that one. Wow. Whoops. That's kind of neat looking, though. Which means the image on the left is not going to go so well. The image on the left is going to look like junk. Apparently there was a lag. Oh yeah, there was about a 2 or 3 minute lag there. Whoops. Apparently for some odd reason it like lagged horribly. Oops. That's alright. But it's back. Okay, so the image is done on the left. It's gonna look like junk only because the guider decided to crap out for a minute. But we'll be able to get more information because it's a 10-minute image. And they look good. And I'm pretty happy about that. So we'll be able to shoot 10 minutes without any problems at all. Yeah, that looks good. Yeah, so what I'll do here, I'll show you. It did the same thing with both of them here. The jig, the jig, jig. Zig, 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 zig. Right there. Look at it, it was like... Yeah, it did it out with both of them. Alright, so the cave's gonna be right here on the image on the right. Because you're gonna have these 3 stars, so it's gonna be right in this area right here. So what I'm gonna do is I'm gonna leave it right here. And we're gonna see the cave right in here on the next image, because now guiding has settled down. Let's see, 2-second images. If we do 200, that's 400 seconds. Yeah, we should be in good shape. And it's at 63%. So we're not going to save this one because this was the bad one. But that is okay. Right now we're at 3.5 minutes already. Reminds you of Starlink. That's funny. But see, this is what happens when you have your guider and you turn the guider off, or it tails off, or whatever it may be. This is what can happen. And you'll get, because what it's trying to do is it's trying to move in one section and it's correcting it. Then it goes back up and then it corrects it again. Meanwhile, declination just gets tailed off, and that's what you're seeing. So the declination is going from top, from bottom right to top left. Meanwhile, the right ascension just keeps bouncing up and down, up and down. And then all of a sudden it decides to stop, and that's why you're getting the bright stars, because that's where it's sat there for the longest. So it moved downward to the right. Yeah, I still haven't seen Starlink yet either. Still a lot of things that I'm missing out on. Whoa. Whoa. Deep Sky Stacker Live was really big. Whoa. I had to move it up so you can see the time. We got 4 minutes left. So by this time tomorrow night, within the next 24 hours, we will be about just at the max of the prenumbral eclipse, which will be technically tonight at 11:07 p.m., which we'll be seeing live, which will be nice. Oh, that looks great. Look at those stars. Oh, those stars on the right are beautiful. That's maxed out at 1.5 magnification. If I were to go down out this here, that is just beautiful. So the Cave Nebula is in this image somewhere. Where's that bright star? There it is. There's the super bright star right there. Where's the other one? Right here. Okay. So it should be right in here. Zoom out a little bit. Alright, should be right in here. Let's play with the histogram here. Yeah, it's right here. This is the cave right here. I know it doesn't seem like much, but it's this right here. Again, it's not much. If I could just make it just a slight bit darker. It might stand out just a little bit more. Yeah, you can see it now. There we go. Now you can see it just a little bit better. Alright, so the 10 image is done. So now, if I were to take this on the camera on the left, oh yeah. Oh wow. Now that's great detail on the camera on the left. Look at that. Wow. We gotta move the, yeah, we'll move the Deep Sky Stacker Live over to the right here. Look at that. Now if we save this and add this to, oh man, this is beautiful. Alright, hang on. We'll get rid of number 8 because that was garbage. Alright, batch save. Save that one. So now it's going to go with the stacked image. So here we go. So now it's going to stack it. And it looks so crazy. It almost looks like it's like an outer ring, like condensation, but it's really not. That's the actual nebulosity on the actual image. That's crazy. Now let's go back and let's do it this way here. We'll go 33% here. There we go. Look at that. Now that's really awesome. You're getting so much detail just in that part of the cave where it actually looks like it's like cracked. It looks so cool. It just looks amazing all throughout here, and then it like has so much detail in the area here, and then when it hits the star here, look at this open little detail all right through here, and then when you get over here, it's got open right in here. I mean, yeah, you have to use your imagination a little bit, but once I stack these on top of one on top of the other, and if I can get like 6 of these, this is going to look amazing. This is one single 10-minute image. Let's see if I can make it, I don't want to make it too much darker, but that's phenomenal. And keep in mind, this is at like 40 degrees above the horizon, so as it's going to get higher and higher, it's going to get darker and darker. And if you ever get a chance, definitely take a look at the cave, and you'll see the actual detail. It's crazy. And guiding is just freaking amazing tonight. We're at 0.59. What are we at for... No, because that's at 400 steps. If I go to 50, we're at 0.49. we're guiding at 1/10 of a pixel. I could easily go. I mean, I could really bust this out. First, we have to change this because we're at 10 minutes at 7 gain. And then this one's at 9 minutes. Sorry, I never changed this. It's close. There we go. But that's really, really good. See if I can pull out a little bit more detail on the stacked image here. That's pretty darn good right there. I had a Thai curry today, which was pretty awesome. Mango habanero was that's bringing the heat. Mango habanero was, oh, that was some tough. That was some good stuff. Yeah, we're guiding is just really good tonight. And we'll be taking... How many have we gotten so far? Let me see. We've taken 2 10-minute images. That's 20. So we've taken 32 minutes so far. So I would say about another 10 minutes or so. So I'd probably go 32 minutes. The image after this one will go to the bubble. If guiding stays just like this, then we'll be in great, great, great shape. I mean, this is the full image here, and you can't see much on the camera on the right. I mean, here's that bright star right there, and then if you go to the left, this is where the cave is here. So all of this would be nebulosity all throughout here. But of course, naturally, you're not going to see much because it's a colored camera, and you have to use nebulosity to really stretch the image. So again, what we'll do is we'll take the last image we took, and we'll go to nebulosity. And we'll pull that up. I mean, I love OBS. And what OBS is, it's a great program that I can use and have different windows. So I can have, you know, Deep Sky Stacker Live, Nebulosity, both camera programs going, my astronomy program going, my guider going, all going at the same time, and yet still keeping it organized, which is phenomenal. And I think that's the greatest thing in the world. So this is the latest image we took with this. And what we're going to do is we're going to go right down to where the cave is, which would be right in here. So, let me see. Move it over right about there. Alright, so we're going to try to see if we can bring out just a little bit more detail here. And it's just very, very faint. And if I take this and do a one-shot color, extract the red, yes. And now zoom in. And again, this is a 9-minute image, and we're not getting much, if anything. It's there. It's right there. But you don't see anything. And that's just crazy. That's nuts. That's a 9-minute image and extracting the red. And we'd be here trying to figure it out forever and ever. That's how crazy that is. Oh, and the next image is done for the 10-minute too. We can close that out. Alright, so we'll take one more with the mead. That's just amazing. Hot dang. Now let's save it. Alright, here comes the next one that's going to be saved. Yeah, you can't see anything with that. Only because the reason being is it's a colored camera. And it can only pick up the most vibrant, bright hydrogen alpha objects. I mean, it can pick up the Horsehead, it can get the Orion. It did fairly well with the Veil, and it did okay with the Satyr Complex and the North American Nebula and Pelican Nebula, but when it comes to an object like this, you have to take the next step. So if anyone out there is, if they're looking to try to get this with a colored camera with a hydrogen alpha filter on there, don't. We could stack this and see what we get, but again, don't get your hopes up on it, because the stars match up, but it's just it just doesn't work out. I mean, we're taking a 10 image here on the left and a 9 image on the right, and it would almost seem like you're taking, almost seems like you're taking a 20-minute image on the left. And that's how incredible that is. Yeah, there's no clouds in the area either, so we're doing really good. We're doing really good. Now we'll flip it to we'll go back to the bubble, but this time we're going to do it with extreme exposure. Whew, 2 million on the Scoville scale. Wow, that's hot. And I think this is, you know, with this channel, and this is going to be a great, you know, experience that everyone can see of what you can do. Now, last night I was going over a little bit of detail of the Bortle scale. And what that is, again, it's light pollution. They base it on artificial brightness, okay? And we'll have a little bit of lesson, a little bit of story, and how this works. Okay, so they base it on artificial brightness is street lights, your house light that's in the front of you, you know, all the brightness that, like parking lots, that's big. Street lights that are on the street. Anything that could cause light in the sky. Okay? That is man-made light. Alright? So, what you'd want is you want to be at the absolute lowest man-made light. If that makes any sense. Where I live, it's in the red zone, which is the second worst. And actually, you know what? We have time. We have time, right, people? Here we go. Let's do that. Let's do this. I'm gonna pull this up because we got time. We got a little bit of time here, right, everyone? Alright. While we're waiting... Here. Okay. Now. This is my website. Alright? Now, I did this over 6 years ago. Okay? And I'm going to read it a little bit with everyone, so you can get an idea, okay? What we got here is Volume 1, Issue 4, and this was explaining light pollution, which is Astro Basics, what I used. Haven't done this in a while. We'll get back into this in the winter, where I'll start making more articles and stuff, so this way everyone can look, read, and understand astronomy and astrophotography. Now, the picture that's there, I took that. That's the Eagle. That's M16. That's the Pillars of Creation. Every picture that I did those for are my images. And then I use Photoshop for the background and for the shading and for all that stuff. But I'm going to go over. This is a little bit of a learning curve, which is nice. Okay, so light pollution is what we measure the seen skies throughout the world. It is classified into 8 different categories. How the classes are determined is depending on where the light is in each village, town, or city, etc. You can do suburb or whatnot. But to get a better idea of each category, I will describe each one of them to you in this section and go from there. Okay? Let me explain the Bortle scale. Alright, I know this is a little small. Get your magnifying glasses, get everything in there. But this is what it is. Alright, so the first one is white, which is classified as horrible. Okay? And what that means is many stars making up familiar constellation figures are invisible, and dim constellations such as Cancer, Pisces are not seen at all. Aside from perhaps the Pleiades, No Messier objects are visible to the unaided eye. The only celestial objects that really provide pleasing telescopic views are the moon, the planets, and a few bright star clusters. The naked eye limiting magnitude is 4.0 or less, and you'll see about 20 stars in the night sky. That's it. So if you're in the white, not good for astronomy. You might be able to pick off a few objects with a telescope, but not much. Okay? The next one from that is red, and that's where I'm at. Okay, so I'm in the red zone, which is called very bad. The entire sky background has a vague grayish-white hue. Strong light sources are evident in all directions. The Milky Way is totally invisible, or nearly so you can't even see it. Clouds are brilliantly lit. Even in the moderate-sized telescopes, the brightest Messier objects are pale ghosts of their true selves. The naked eye limiting magnitude is about 5.0. If you really try, and I have tried, the highest that I've ever seen from out here is about 3.7, 3.8, and that's 52 Cygni, which is where the veil is. I haven't seen any 4th magnitude stars out here, even if I tried. Okay? And a 32 centimeter reflector will barely reach 14th magnitude. Less than about 100 stars would be visible. So if that makes any sense. So if I were to look up right now, I would only see 100 stars. That's it. It's plain and simple. If I were to travel about maybe 5 miles south of here, I can get into the orange. And orange is classified as bad. Okay? Any indications of the Milky Way are apparent only toward zenith. Or zenith, however you want to... Uranus. Tomato, whatever. Sky within 35 degrees of the horizon glows grayish white. Clouds anywhere in the sky appear fairly bright. You have no trouble seeing eyepieces and telescope accessories on an observing table. The naked eye limit is about 5.5, and 32 centimeter telescope used at moderate powers will show stars at about 14 to 14.5. So that's orange. If I were to travel about 10 to 15 miles south of here, you can get into the yellow. And that's average. The Milky Way is very weak or invisible near the horizon and looks rather washed out overhead. Light sources are evident in most, if not all, directions. Over most or all of the sky, clouds are quite noticeably brighter than the sky itself. The naked eye limit is around 5.6 to 6.0, and a 32. And I use 32 centimeter reflector is a nice, easy guide. We'll reach about 14.5 to 15. Okay. Now we're gonna start getting even darker. All right. So now we're into green. Okay. Green is above average. Fairly obvious light pollution domes are apparent over population centers in several directions. The Milky Way, well above the horizon, is still impressive but lacks all but the most obvious structure. Clouds in the direction of light pollution sources are illuminated but only slightly so, and are still dark overhead. The maximum naked eye limiting is about 6.1 to 6.5. So now you're seeing dimmer and dimmer stars. Okay, so now you get into blue. Okay, now we're getting even darker. Some indications of light pollution is evident along the horizon. Clouds may appear faintly illuminated in the brightest parts of the sky near the horizon, but are dark overhead. The Milky Way still appears complex and evident. The naked eye limiting magnitude is about 6.6 to 7.0. Long exposure astrophotos might show some light pollution gradient, but visual observing is relatively unimpaired. So now we got the last two. Okay, so now we're down to gray, which is very good. Airglow may be weakly apparent along the horizon. The summer Milky Way is highly structured to the unaided eye, and its brightest parts look like veined marble when viewed with ordinary binoculars. Any clouds in the sky are visibly only as dark holes or voids in the starry night background. Many of the Messier globular clusters are distinct naked eye objects. The limiting magnitude for naked eye is faint as 7.1 to 7.5, and that's Cherry Springs. Okay, Cherry Springs is in Pennsylvania. So that would be like in Coudersport, Pennsylvania. That's gray. And Kim, we're going to go over where each place is, which is going to be awesome, okay? So for black, that's excellent. This is like if you would go to Spruce Knob in Virginia, if you go to Arizona, I think it's the Joshua Tree, I think is where it is. There's one in California. Anything that's west, you'll be able to get into the black. And that's nirvana. That is just crazy. The Scorpius and Sagittarius region of the Milky Way casts obvious diffuse shadows on the ground. To the unaided eye, the limiting magnitude is between 7.6 and 8.0 with effort. The presence of Jupiter or Venus in the sky seems to degrade the dark adaptation. With a 32 centimeter, which is 12.5 inch scope, stars to magnitude 17.5 magnitude can be detected with effort. This is an observer's nirvana. That's crazy. And it's just nuts. So explaining by the numbers. So here we go. So this is the explanation. Along with the color scale above, there's numbers to determine the natural brightness in places around the world. 0.00% natural brightness is the sky with no man-made light, which creates an amazing view of the sky. The numbers below are determined on the percentage over the natural brightness. The higher the percentage, the brighter the sky and the less we can see. Makes total sense, right? So, white, which is at the very bottom, we're going to go backwards. So white, which we just went over, is 2,700 to 8,100% above natural brightness. Red is 900 to 2,700, orange is 300 to 900, 100 to 300, 33 to 100, 11 to 33, 1 to 11. Black is less than 1%. Makes sense? Did a little map, which is nice too, so you can see that too. Okay? So, I'm going to move this out of the way here. There we go. So notice that when you're near the city of Arizona, I picked Arizona just because it's fun, because you get all the colors in one little section. So notice the city of Arizona, the light pollution is huge, but heading east of the city, going into a park away from the city, the light pollution becomes non-existent. You could go 25-30 minutes away from the city and you could experience all 8 in the light pollution. That's crazy. That is absolutely crazy to actually witness all 8 of them in just a very short period of time. So that's why I did it with that. Now, here's the cool part. Ready for this one? Here's the awesome part. On my website, which you can visit at elliot-astronomy.com, you can go right up to the very top and hit home. Okay? You have my website, which is right here, everyone. By the way, this is my hand controller right here. I don't know if you noticed that, but this is my hand controller. I gotta get that out of the way. Okay? And I haven't updated the site in probably about 6 weeks. And yes, I know the pen giveaway. Joanne, I did send out the pen, so just letting you know that. Alright? So, when you're looking at this, this is what's called lightpollutionmap.info. I added this to my website, so this way you could see it. Alright? So that's Washington right here. But you could type in your address or any address you want and find out what your light pollution is based on color. So if I were to zoom out, this is just like a map overlay of everything. So you can find out where you live in the United States, but look how it's cut in half. Look how crazy that is. This is the eastern, central, Midwest, and West. Look at that. Look how many black, you know, look at that. That's crazy. You got black and gray all throughout here. Just very limited spots like Arizona. You got Las Vegas. And just little spots there. But when you look at the eastern seaboard, you got all the big cities like Philadelphia, Washington. But look where Spruce Knob is. Look at this. You can see the sucker hole where Spruce Knob, which is in West Virginia. And then you have Cherry Springs, which is right here. So you have those two spots. These are the darkest spots in the eastern seaboard. That's it. Everything else is pretty much full. Look at Florida. So it's pretty crazy that you could see everything. So give it a shot. You know, try it out. And then if you ever wanted to know what your longitude and latitude is, if you just put your mouse over wherever the certain spot is, it'll tell you what your longitude and latitude is. I mean, how cool is that? And then, of course, I have the little guide on the bottom to tell you 2700, 900, 300, 100, 33, 11, 1, and less than 1. So it has all of that, which is really cool. So, yeah, just a great little tool that you can use. So, while we were doing that, we're still taking images, just to let you know. We have taken 2 10-minute images since then. We'll batch them both. But that's a great little learning tool. I figured I'd do that, which is nice. And now we're going to stack the next 2 images here. So we'll wait for that to go through. So here we go, it's loading. And now it's stacking. Looks really good. Oh, it's looking really good. Dang. Right, where do we stand for images right now? We're at 2 minutes. We'll stop it when the camera on the right finishes. Because that's at 86% right now. So when that one's done, we're going to flip it to the bubble. Let's see what the last image looks like with the camera on the left. Oh yeah. So here's my question. Here's the $1,000,000 question. Should we keep going with the cave and get as many as we can, like say we get in about another half an hour? Or, because guiding is so good right now, because we could try to push this to 12 minutes if we really wanted to. Or do we go to the bubble? What should we do? And where should we go? And by the way, I got mouses for both computers now too. So now I can easily go back and forth. I have 2 mouses for both computers. Everything's good. The TV's going to be going up in this room, so I'll have a big 42-inch TV in here, so I'll be able to see it a little bit better instead of me crouching over 2 laptops. I'll have the big TV on there, which will be great. We're doing good. Let me see. That's why now I can go and do, you know, for the Deep Sky Stacker, I can easily zoom in and zoom out if I have to. Oh, and there's clouds coming through. Oh, snaptastic. The image is done with the camera on the right, but look, oh boy, we may have to end it. These are little clouds that just went through, but if I were to... Here, I'm going to move this up here. There we go. Look at the clouds coming through over on the right side of the bottom right. Right here. There's clouds coming through. We may only be able to get one more on the meat, and that depends on what's coming up after that. I don't know. So we'll see here. See what we get. 15 seconds here. We'll see what's next. Exactly. Go away, clouds. Oh boy. Where do we stand right now? We're at 6 minutes and 2 seconds. If we can get one more, I'll be happy. Because that would be 50. So we'd be at about an hour and 20 minutes. By the way, this is a live image, so it's taking 60-second exposures, one after another, so 4 seconds, and then we'll see what the clouds do here. Oh boy. Doesn't look like anything after this cloud, so we'll see. We'll get this last image. And then I think while the clouds are coming through, we'll move to the bubble. But we'll see. Take a look. Unless if we want to stay with the cave. Because that's 1 a.m. And we're going to be back out here again tomorrow. This time we'll add one more aspect to it. And we'll add the moon to it, which will be awesome. We're going to get the wide field of the moon, again with the penumbral eclipse. Now what that means is, again, it's not a total eclipse, okay? A total eclipse is you would see the blood moon, what people say, and you'll see that. But with this one, it'll look like it's half, about 40% of the moon's going to be shaded. And if you have the right equipment, you'll be able to see it. So the actual definition of it's a penumbral eclipse is a penumbral eclipse only occurs when the sun and earth and the moon are partially aligned. When this happens, Earth blocks out some of the sun's light and directly reaching the moon's surface and covers all or part of the moon's outer part of its shadow, also known as the penumbra. Which makes total sense. It's pretty explanatory, but you never know. So that's what we're going to be seeing tomorrow in all of the United States. So we'll be able to get that, which is going to be super epic. And I'm super excited for that. I will have my Canon T3i pointing at that. I will have either my Orion Apex 90mm or my Astroscan Millennium, which is 114mm. One of the two is going to be pointing at that. Yeah, it just looks like there's just one cloud band going right through. And after that, doesn't look like there's anything behind it. So we should be good. Let's see what it does here. I don't know. At 10 seconds and this next image is going to be done. Seconds. Perfect. Alright, so that next one is done. So that's great. Alright. We're just taking one after another after another. We are doing great. So now we're going to save this one again. And now we're going to add this to the... Wonderful. So what we'll do here is we'll go back to... Oh, darn it. Did it again. Wrong one. There we go. So it's going to add it to the stacked image. So here we go. We'll see what it does. Here we'll zoom in. Here we go. It's stacking. Perfect. All right. Yes, welcome, Chris. Yeah, we're getting the Cave Nebula. I don't know, which is actually technically, we can even do the story time. So we gotta love story time. Why not, right? It's a little quick story time. Ready? Oh, here we go. The Cave Nebula. Sharpless 2-155 or C9, either one. The Cave Nebula is a faint region of hydrogen A, which is alpha, emission in surrounding dust in the constellation Cepheus or Cephas, one of the two. It is a dim and very diffuse bright nebula. I love how I read that. Dim and bright. Interesting. Within a larger nebula complex containing emission, reflection, and dark nebulosity. Visually, it is a difficult object, but with adequate exposures, it makes a striking image. The nebula gets its name from the dark lane at the eastern side that has the appearance of a deep cave. Who knew? Because that's what we got right on our screen. How awesome is that? This area is rich in detail, which is especially prominent when imaging in hydrogen alpha light. In addition to the central cave-like structure, notice the subtle patch of blue reflection. Now we can't do the blue patch because we're shooting in hydrogen alpha, but there's blue reflection nebula in the upper right portion of the field. Now where that would be is right where that star is. So if you were to look on the camera on the left with a deep sky stacker live, this is the star right there. So right where my mouse is, there'd be blue nebulosity along the edge right here. We can't see that because we're shooting in hydrogen alpha. The Cave Nebula lies about 2,400 light years away and has a physical diameter of about 70 light years. This corresponds to apparent dimensions of about 50 by 30 arc minutes. That's big. That's very big. So you can get an idea of that. So you have it for that. So that camera's done. Here come the clouds. Alright, so we're going to stop the guider. Alright. Stop the exposure there. The other camera's already done, so we're set with that. We're going to wait for the clouds to go through. Okay. Perfect timing, by the way. Absolutely perfect timing, because we're going to go back to the wide field and look at the clouds. Look at those clouds. Oof. That's what's just coming right through. Whoosh. The clouds. Clouds are just coming right through. Now, here's what we could do. We could wait for the clouds to go through. Or we could take just a sneak peek of the bubble for about 20 minutes, and then we can call it a night. What do we got? We got Kim. We got Stacy. I don't know if Stacy's still on. Chris from Astro Live channel. Jello. What should we do? What should we do? Should we stay imaging the cave? Just a couple more exposures, so this way we get its maximum exposures? Or do we want to see what the bubble looks like in hydrogen alpha? Talk amongst yourselves, and we'll see what we get. Stacy's still here, she says. Stacy, what should we do? Should we go for the bubble, or should we stick with the cave? Bubble. Yeah, we're going to the bubble. Hell yeah. Alright. Let's take a look and see where we are. Okay. Alright, so we just moved it. I want to see the bubble too. You damn right I do. You damn right. Alright, let's take a look and see where we're at. We're taking a 40-second exposure here, so let's go back to my long exposures here. And what we'll do is we'll get rid of the Deep Sky Stacker Live, so this way we can see what we got here. Taking a 45-second exposure on the camera on the left. So let's see what we got. I just moved it just slightly, so... And you could see that the Cave Nebula on the bottom left on my astronomy program, you could see this is the cave right here. That little purplish square. And then down up the bottom left, this is the bubble at M52. So we should be able to see both of them in view. So let's take a look and see. Let's take a look. Oh yeah. Oh yeah. We're right where we need to be. Oh my god, that's like almost dead center. Alright, perfect. What I want to do now is just get this down just a slight bit. Oh, that's perfect. Okay, and I'll go back to cider reel and hit west, because we want to get this down just a slight bit here. Perfect. So now we're moving it down just a slight bit. Okay, so right about... Here. That's perfect right there. Okay. Let's see what it looks like on this one here. Let's take a look. We'll take a 10-second exposure on the camera on the right. Perfect. Huh. Let me see here, because I'm just going to move this down just a slight bit here. Just moving it here. Alright, there's the bubble right there on this one. So now it's just a matter of getting M52 in here too. Keep going. Just gotta move that, because I want to get both of them in both cameras here. So just give me a second here. While we're waiting, while I'm getting everything set up here, we'll go back to wide field, see if there's any wonderful clouds coming through to make sure that we're good to go with that, which I think we're in great shape. Yeah, I gotta keep going to get M52. Does anybody want M52 on both cameras? Because I can keep going. I can try to get both of them in view. I don't know if anybody cares. I mean, some people would. Should be right about there. Alright, perfect. Alright. Now we got them both in view. Okay. Alright. Let's start the guider back up. Okay. We'll do a 10-minute exposure. Well, we'll start with 6. We'll start with 6. Just to see what we get. And we go. And we're off. And then we'll pull the planner up for this one. Well, first what we'll do is we'll stop the image on this one. Okay. We'll do a 420-second exposure on that one. And go. Perfect. So we'll get M52 and the bubble. And of course, the bubble, the name on that is NG35. Cut this here. This way we'll be able to get more of the sky here. There we go. And less of the telescope. Because you're getting a telescope over a telescope. Ah! Yeah, that little band of cloud is now gone. Which is epic. Alright, so the next thing what we're going to do is we're going to go back to here. There we go. So we're going to do a 6-minute exposure on the left. And a 7-minute exposure on the right. There we go. So, we got about less than 2 minutes to go. And then we're going to see what we get with this. Now, this is going to be... I hope. I'm really, really hoping this is going to be good. Can only hope so. Clean up my pockets here. There we go. Too much stuff in my pockets, God. There we go. Much better. There we go. 1 minute left on the camera on the left. And we'll see what we get. Should be interesting. Guiding is just phenomenal right now. That number is gonna go down. It's at 0.71 right now. That number is gonna start going down in a second here. 76% on this one. And we got 4 seconds. Here we go. Oh, that's like dead center. You could... Here's the crazy part. You can actually see the bubble without me even touching the curves. That's this right here. You could see it. That is just crazy. That is ridiculous. That's the bubble right there. That is crazy. And M52 sits just up at the top right. So, and then you even have some nebulosity up at on the bottom left here too. That is insane. Wow. And now the other image is done now too. Let's take a look and see what we got for this one. I gotta find it. There it is. So, the camera on the right, all you get, and this is just crazy. The camera on the right, all you get is that bright part of the nebula. That's it. I mean, the way guiding's going, my God. I could easily push this to a 12-minute exposure without any problems at all. I mean, look at that. Just the detail. And the best part is, we could actually get... Let me see here. There it is. It's down at the bottom here. We could get both nebulas in here. Because there's an NGC object that's in that vicinity too. There you go. I don't know if you could see it. Can you? Yeah, you can. Yeah, you can. So you can get the bubble, and there's an NGC object just on the other side of that. And of course, that NGC object is, well, actually, it's an IC object. I'm sorry, it's an IC object. It's IC 1470. And that's pretty darn prominent, too. That's this one right here. And look at this. You get a little bit of nebulosity right here. Little nebulosity over here. And then even some on the left-hand side, which is right here. And some here and some there over here. And then you even have the faint nebulosity all throughout the bubble, all throughout here. My God! I'm so glad we went to the bubble. Thank you, guys. That just made my night. Oh, the next image is done too. Sweet! So now we can start stacking them. So let's do that right now. Documents, sky capture, 7.4. Take these ones, cut them, go back into here, go to 7.3. Paste. So this way we'll get rid of that. Okay. We don't need that one. Alright, then we're going to do a batch save. And then this is going to be NGC 7635. Save, yes. Okay, yes, and stack. Here we go. So now we're going to do the next one. So here we go. So now we're going to go and we're going to do... Okay. Perfect. So now it's going to load the first image. Here we go. Oh, man. Oh. Holy wow. God. Dang. Wow. That's incredible. So there's the... Right there, that's the IC 1470. That's just mesmerizing. That's amazing. There you go. Now you can be able to see the bubble a little bit better. That's amazing. Oh, next one is done. I'm going to stop it. Batch save. Yes. Now it's going to save the next one. And then now what we're going to do is we're going to increase the exposure. We're going to go to 10 minutes. And go. Alright, so here we go. It's loading the next one. So this will be 18 minutes. Nice. That is just mesmerizing. gonna probably increase the exposure a little bit on the camera on the right. Okay. So force stop that. Okay. We'll do a 12-minute exposure. We'll see what we get on the camera on the right. We'll take a 12-minute exposure and then we'll see what we get and then we'll call it a night. So one more image on each and that will be it. No clouds coming through either, so we're good. No clouds, it's just high rising right now. And now you can actually start to see Cassiopeia in the wide field. And I'm going to pull that up while we're waiting for the image here. Cassiopeia sits up at the top here. So I'm going to use the mouse. It's going to be this right here. Just barely up at the top. This is Cassiopeia right here. How cool is that? Actually, what I'll do... actually bring it down here. There we go. Now you'll be able to see it a little bit better. Perfect. What's the temperature outside? Let me see here. .74. I should be able to open up the window a little bit. It's getting hot in here. There we go. It's amazing. And by the way, we're taking images of the wide field too, so I can make a movie of it if I have to, which is really cool. It's 60-second exposures, and you'll be able to watch this go through the night, which is really cool. So if we had any meteors or anything, or any shooting stars, if they're super, super bright, that is, too. I'm in the midst of trying to figure out what I can do for an all-sky camera, which I haven't gotten to yet, so we're working on that. It's still pretty darn awesome. Alright, so the first image is now done on the camera on the left. Alright. This is a 10-minute image. So let's do a batch save. And we can actually watch it go adding with the DSS to see what we possibly can get. Maybe there's a little bit more detail that it's going to pop out. Let's see, it's loading. Stacking. Let's see what happens. Nice. Nice. A little bit more detail that actually puts in there around the outside edges. Nice. Freaking love it. Right, now let's take a look and see what we get. Let's see here. What do we get? Oh, that's beautiful. That is just mesmerizing. get a little bit closer here. %50 here. There we go. Welcome back, Rob. See if I can pull out a little bit more detail in the Deep Sky Stacker Live. There we go, that's a little bit better. Now it's going to be a little bit grainy on the Deep Sky Stacker Live only because it's got the hot pixels and it's not doing any calibration frames or anything. If I were to do this the right way, this would be a flat image. The camera on the right is done. Whoa, that's bright. A little bit of drift on this being a 12-minute image. Huh, interesting. And we're still not getting anything for the bubble. That's ridiculous. That's crazy. At 12 minutes, I don't think I can get on the camera on the right. I'm gonna have to go back down to 10 minutes. Wow. That's just mind-blowing. We're at 0.49 arc seconds of guiding. And we're guiding at 0.1 pixels. That's just incredible. Wow. Mind-blowing, everyone. I can't wait to delve into these images and see what we got and see what we can do with these. We're just piling these images on, one on top of the other. Absolutely amazing. Well, the ISS is rising right now, but it will not be high enough for me to see it, unfortunately. The highest it gets is where Aquarius is, and that's about it. Where we're shooting is we're shooting way up north. Well, the next image is now done. And that is all she wrote. Because it is just about 2 a.m. We're letting the last one stack here. So on DSS, we're going to watch it stack. And it just stacked the 5th image. So that's it. So everyone, thank you for coming on tonight. It has been an absolute awesome experience. As always, the plan worked exactly as I wanted to. We got the 2 objects. Everything is great. So, with that being said, happy 4th of July out to everyone. Make sure everyone is safe and healthy and happy. We'll let this song play out. And we will see everyone in just a mere 20 hours as we will get the prenumbral eclipse and also do some deep sky imaging also at the same time, because we got some more objects to get, which is going to be friggin' awesome. So you guys have a wonderful night. We're going to end this as soon as the song is over and we're out of here. So you guys have a wonderful night, and I'll talk to you guys later. Bye.